Biotic constraints within APSIM. We've often talked of APSIM being a farming systems model, and it's becoming more and more of that, as you've heard, with livestock and multi-paddocks and pastures being incorporated. But one of the things we haven't had in there is pests and diseases. So this is a piece of work that we're working on. So basically, we've taken two modelling systems. We have APSIM and we have DIMEX, which is another CSIRO modelling system, which is a population modelling framework. So I'll just step you through basically both systems. APSIM I'll be pretty quick on because I think most of you will, after the rest of the talk, should be fairly familiar with. And then I'll talk about DIMEX and show how we've joined the two together. So thinking about APSIM, it's based around the soil. Crops come and go. They change, find the soil in one state and leave it in another. If we start thinking about wanting to include populations or diseases, and for this stage, let's think of these little red dots as, say, weed seeds. Some crops, you may have a high population of weed seeds. Due to the rotational sequences, you may be able to reduce those weeds with chemicals, and then they'll build up over other crops. Likewise, that could be a disease, a soil-borne disease that is susceptible in the first crop, reduced in the second crop, and building back up in the third crop. So trying to manage those populations within the farming system is what we're trying to do. So we're using DIMEX. DIMEX comes in two parts. First part is a builder, which allows you to build the population model, and then a runner, which runs that population model. So what is DIMEX? It's all, if APSIM's based around a soil, DIMEX is based around the life cycle. So basically the life cycle of an insect, a disease or a weed, it doesn't matter what it is. It can be a crop even. And with that, you can find how it transitions from one state to the other. And you have births and deaths and mortalities so that you can end up with a final population. So, how did we put that into APSIM? I say a very royal we. How did Neville put that into APSIM? Basically, and I'll probably get this wrong, but we've built a wrapper that wraps the DIMEX engine, the simulator engine. So you still build a DIMEX model in the DIMEX builder, being aware of which inputs you're going to need from APSIM. You run that and you put that in, and that's wrapped, and the simulator is wrapped, and you feed in your DIMEX model and it runs within APSIM. So basically how the DIMEX link works is, in this case, you've got APSIM working on its daily time step. It feeds some information to DIMEX. DIMEX can work on a sub-daily time step if needed, if your disease or whatever multiplies at very fast rates. It will work through the DIMEX bit and it will then feed back information. So to give a working example, what I've used here is rust. So APSIM feeds DIMEX a leaf area. DIMEX grows rust on that leaf area, therefore we have reduced the leaf area. It feeds back to APSIM that you now only have this much leaf area at the end of the day. And I'll work through that example in a minute. Firstly, build your DIMEX model in DIMEX. This is what it looks like in the standard DIMEX. You can test your model in the DIMEX simulator or run model, and that's basically what it looks like, where you can get your outputs. And this is what Neville's built. So this is the DIMEX APSIM link, where that runtime module has now been incorporated into APSIM, and it appears there in the tree just as every other module in APSIM does, and it can talk to the other modules within APSIM. At the moment, that talking has to happen through the manager module, but we're working on fixing that. So, some sort of results to show how it works. I talked about rust. This is an example of a rust model that was written in DIMEX by Neil White around about 2000. He's allowed us to use his rust model. We've incorporated it into APSIM. We've run the model here. So this is just showing different resistance, rust-resistant wheat lines, and how the rust changes over time, and whether it was very susceptible, or how leaf area in APSIM changes over time. So to try and point it out, this is with no rust. The red line, well, you probably can read it up there. So no rust, resistant crop, down to the lower one, which is showing that there is they're susceptible to rust and a large deal of leaf area has been removed. Again, it was leaf area. Again, so looking at the same thing, but looking at the initiation of rust. So within Dymex, we can say that there is so many million spores floating around free every day, or we can reduce the inoculum at the start of the season. And this shows basically if you have a high population of a large amount of inoculum at the start of the season, you will have a much bigger rust infection on your wheat crop than if you have a small or zero initiation at the start. So just showing how the Dymex model is influencing APSIM to give a different result. And again, just showing over time, so doing a long-term simulation, different seasons, these all had the same initiation, so the same inoculum at the beginning of each season, but the way the seasons panned out, the rust either took hold and reduced leaf area or didn't. So again, the black lines there, should probably be using this. The black lines here are showing where there's no disease. The red lines for the resistant, so there is a little bit of a reduction in leaf area, and then the susceptible had a lot of disease and a large reduction in leaf area and yield. So in the future, the moment you start working on a problem, you start finding lots of other areas that need work. So building better leaf wetness models is needed, and starting linking to build more diseases such as root diseases, and we're currently working on a nematode model. I think that's probably it. The first question most people will ask is, when can we use it? Yes, it is available. No, it is not part of the current download of APSIM and probably won't be for a little while. But if you're interested in working with Dymex and APSIM together, contact us, and I'm sure CSIRO will come to an arrangement for an open collaboration with you to develop something.